Okay, so today we're doing 2-5, which is algebraic proof. Okay, and like I said, I did give you a word bank, but there are some different things that we're going to go over. So we're going to turn over our note sheet to the back. Okay, and we're just going to write 2.5 algebraic proof. And I'm just going to give you a second to look over this. No, don't write the whole thing down. I just want you to read it for right now. Hey, reading does not require having a conversation with your neighbor. Weird. Okay, so the first few properties we're going to go over are the properties of equality. And we have 3 of them. You have addition, subtraction, multiplication, and division. So here they give you some examples. If A equals B, then A plus C equals B plus C. Really what you're going to see from one step to the next is you're going to see that something was added to both sides of the equation. For subtraction, something would be subtracted from both sides. Multiplication, something would be multiplied to both sides. And then division, something would be divided by both sides. So there are addition, subtraction, multiplication, and division properties. Okay, and these are used when we either add, subtract, multiply, or divide by the same value on both sides of the equation. Okay, so these are different properties that are going to be used when you add, subtract, multiply, or divide on both sides of the equation. The next one, you have a reflexive property. So the reflexive property is like a reflection. Okay, so it would say something like A equals A. It would be the same on both sides. You can also see there's properties of congruence. So there's the reflexive property of equality. When 2 things are equal, and then of congruence when 2 things are congruent. So a lot of times you'll have like a segment is congruent to itself. Okay, you will have the exact same thing on both sides. Okay, and when you are using the reflexive property, whether it's of equality or congruence, you can just write reflexive property. You don't have to write of congruence or of equality when we're writing those down. The next one is called the symmetric property. And when something is symmetric, what happens is they switch places. So they'll be the same values but in a different order. So for equality, you could see if A equals B, then B equals A. Okay, so you can think of that like a flip. And then for congruence, you'd have something like angle 1 is congruent to angle 2, or if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. So again, it's the same values, but they're given in the reverse order, so in a flipped order. Okay, and then the last one is called the transitive property. And the transitive property is like a transfer. Okay, the transitive property is like a transfer. So there's going to be 3 different variables here. And this says if A equals B and B equals C, then A equals C. Okay, so if A is equal to B, but B is equal to C, then A and C are also going to be equal. So it's like that equality is going to transfer. If you have segments, that could be one with congruence. So if PQ is congruent to RS, and RS is congruent to TU, then PQ is congruent to TU. Okay, so those 3 are going to go together. The reflexive, the symmetric, and then the transitive property. We also have the substitution property. And that's when you substitute one value in for another. Okay, so that's used when you substitute one value in for another. And I am going to give you an example of that. Okay, so an example would be if you know the measure of angle 2 equals 80 degrees, and the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Oh, sorry, I'm going to start with if. Then, instead of saying the measure of angle 1 plus the measure of angle 2 equals 180, you could say the measure of angle 1 plus 80 degrees equals 180 degrees. Okay, so you're substituting in the value of 80 degrees for the measure of angle 2. Okay, and that would be substitution. Okay, so now we're going to flip it over to the front. Okay, so your algebraic proof. So the first thing we're going to talk about is a proof. So a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Okay, so this is called a proof. Okay, and then we're gonna do some highlighting for our important parts here. Okay, so a proof is an argument that uses logic, definitions, properties, and previously proven, not proven, proven statements to show that a conclusion is true. Okay, so basically if you are claiming that something is true, you have to have the proof to back it up. And so that's what we're going to work on doing with our proofs today. So an important part of writing a proof is giving what is called justifications. You probably have heard the term justify a lot, so justify your answer, which means to do what? Yeah, you're trying to give evidence to show that that's true. Okay, so we're going to do something similar here. So we're giving justifications to show that every step is valid. For each justification, you can use a definition, a property, or a postulate, which we wrote down for you. Alright, so for this example, we're going to solve the equation, and we're going to write an example for each step. So the first thing you want to do is start with what you are given. So I am given this equation, okay? So when I start my proof, I'm always going to start with what they give me. So negative 5 equals 3n plus 1. And then how do I know that? It was given. Okay, so that's going to be my justification. Pen's running. Okay, so Jared, if I was solving this equation for n, what would I do next?
You get 3n on one side and regular numbers on the other side.
Okay, so I already have 3n on this side, so let's move this number over. How would I move the 1 over?
Change the sign.
Subtract 1 from both sides.
You would subtract 1 from both sides, right? So if you're subtracting 1 from both sides, what's negative 5 minus 1? Negative 6. And then this side would be 3n, correct?
Yes.
So what did Jared say that I used to move the 1 over? Subtraction. So this is going to be the subtraction property of equality. Okay, and if you want to put the actual steps in between there, that's perfectly fine. When you see it in a proof, it will look like this. You won't see like that part of the work, but that is how we got there. Okay, and then Brandon, what will we do next?
We'll divide by 3.
Okay, so we're going to divide each side by 3. So then I'll have n on this side. If I divide 6 by 3, what do I get? Negative 2. And then what did we use to get there? Division property. Yeah. Okay, so the division property of equality. Okay, and then then that's it. We solved it and we justified each step. Okay, do you guys have questions for me on that? Not too bad yet? For these, yes. As we get more into it, I'll just like write property. Okay, and then the next example, it says, what is the temperature in degrees Fahrenheit when it is 15 degrees Celsius? Solve the equation with the given formula and justify each step. So what we have to do is find the temperature in degrees Fahrenheit when it's 15 degrees Celsius. And then we have to make sure that we solve the equation and we're going to justify each step. And this should have a C in it. This should be a C here. Okay, so solve the equation. F equals 9/5 C plus 32. And then we're going to justify each step. Okay, so the first thing we're going to do is start with what we are given. Riley, what are we given in this one?
15 degrees Celsius.
What else?
And the equation behind what is Fahrenheit.
Okay, so let's start with Fahrenheit equals, and I'm going to write it as 9/5 Celsius plus 32. And then that is what we were given. Okay, Tanner, what do you think we're going to do with that 15 degrees Celsius?
Put it in C.
Yeah, so when you were given that this is 15 degrees Celsius, that's going to be your C value. Okay, your C value is going to be 15. So I'm going to go ahead and plug that in. Okay, and Kaylin, what property do you think I used to do that stuff? Yep, substitution. So I substituted in 15. That's going to be the substitution. And we can just write prop of equality. Okay, so now what we're going to have to do is simplify. So I can multiply 9/5 times 15. We're going to do that without a calculator. So we're going to do that on the side over here. If you do 9/5 times 15, you can think of 15 as what?
15 over 1.
Yeah, 15 over 1. Okay, so you can actually find common factors that go into both. So see how like 15's on the top, 5's on the bottom? It's like you're dividing them. How many times does 5 go into 5?
Once.
1 time. How many times does 5 go into 15?
3 times.
3 times, bless you. So then we can just multiply straight across. It would be 27 over 1, which is just 27. Okay, so then I would get 27 plus 32. Now, your reason for this is going to just be simplify. Can you or anybody tell me why it would not be multiplication? Yeah, Dan? Okay, good. So you only use the multiplication property of equality if you're doing the multiplication of both sides. Okay, we're just simplifying here by multiplying those two together. And then we're going to simplify one more time by adding those together. So F would be 59. And again, that would be simplify. Okay, so when it's 15 degrees Celsius, it would be 59 degrees Fahrenheit. Okay, and that would be your solution, your 59 degrees Fahrenheit. Okay, for the next one we have a picture. So we have this line, we have N, M, and O. we're given NM is 2x, MO is 3x minus 9, and the whole segment there is 4x minus 4. So your given in this case is the actual diagram. So it's this diagram that's going to be your given value. Okay, so then we have this. We have NO equals NM plus MO. Yeah, do anybody think they know what the reason is? That, well, this part isn't. What is this when you have NM plus MO equals NO? Yeah, what is it? The segment addition postulate. Okay, so on your word bank is going to be some other equations and properties that we've already learned about this year. Do you guys remember the segment addition postulate? So the two smaller segments added together make up the larger segment. Okay, so this is going to be the segment addition postulate. Oh, and yeah, this should be an equal sign here. Will you guys change that?
I was confused.
Yeah. Instead of, it says after 4 it says plus, it should say equal. Okay, so let's think about how we got from this step where NO equals NM plus MO to this step. Okay, Avery, let's look at this together. You have NO and then you have 4x minus 4. Where did that come from?
The given.
Okay, so it came from the given. What did I do with this value?
Do with it.
Why or how did you plug this in for NO? It's hard for me to say it without saying the actual word. What just
Aren't
happened?
they equal to or something?
Well, didn't you just replace this with 4x minus 4? Yeah, what do we call that?
Substitution.
Uh-huh. Right? Because we just substituted one in for the other.
Yeah.
Okay, so this is going to be the substitution property of equality. Okay, so then look at the next step. And if you're having trouble seeing what's happening from one step to the next, look at that step above and think about what you would do. Okay, so Tina, what happened from this step to this step? Yeah, you simplified, right? You combined your like terms. So that's going to be your justification, is simplify. Can you guys see that all we did is 2x plus 3x to get the 5x? Okay, and then Hope, what about from this step to the next step? Good, and what did we subtract from both sides? Yeah, perfect, good. Okay, so we subtracted 4x from both sides, and that's how we got x. So if you're having trouble recognizing it from here, wouldn't your natural next step to be to get all your x's on one side? Okay, so you might just be thinking, oh, I'm going to subtract that anyway. Okay, so this is going to be the subtraction property. Equality. Okay, and then Chloe, do you think you can help me with the last one?
Is it
Because what did you add to both sides?
9.
Yeah, so you added 9 to both sides, and then you got x equals 5. Okay, so the addition property of equality. Okay, perfect. Alright, so I'm going to let you write down your homework, and then after you get that written down, we're going to clear everything off our desk because we are going to go over our chapter 1 test that we have not got to see yet. And then after we go over that,